All right, we have another one from 2015. This was question 4. On a traditional AP test, there's typically 2 questions related to inference. This one was a straight up hypothesis test. Nothing special about it. I'm gonna probably go through it a little bit quickly for that reason. As you can see, I started off way too big and I had to write a lot smaller towards the end. I mean, not too bad, but I wrote gigantic for the assumptions. So you can see what they are doing over here. They like to use a lot of words. I don't like to use as many words. They use the formula. We're not using no formula when we can use the calculator here. We're not even going to pretend. But they got, with their fancy formula, negative 1.75, negative 1.7542 from the calculator, which is what I got, and 0.0397 from the calculator. And we did way less work than they did. So we're just gonna jump straight into scoring. So for step 1, you had to identify correct parameters and both hypotheses are labeled and state the correct relationship between the parameters. Just make sure. Yep. So section 1 was actually the hypotheses, even though I wrote it second. Essentially correct if you identified both parameters. P1 is the population proportion of all people who will take a low-dose aspirin and develop colon cancer. P2 is the population proportion of all people who will take a placebo and develop colon cancer. Remember the one from earlier, the way they worded it was a lot better, where P1 is the population of all people who will take a low-dose aspirin, proportion, let me see what they did up here. I want to see if they worded it better. Where let P aspirin represent the population proportion of adults similar to those in the study who have developed colon cancer within 6 years of the study. If they had taken a low dose. So let P1 or P aspirin represent the population proportion of adults similar to those in the study who have developed colon cancer within 6 years of the study if they have taken a low dose aspirin each day. Fairly similar. It really should be all people similar to those in the study. But I think we're okay. So identified correct parameters and both hypotheses are labeled, so HO and HA. And the correct relationship between the parameters, so P1 equals P2 and P1 is less than P2. You can also do it if you saw above P1 minus P2 equals 0, P1 minus P2 is less than 0, if you prefer. I don't know why you would prefer that at this point, but you can do that if you want. So essentially correct right now for the hypotheses, if you have all 3 of those partially correct. If you identified the correct parameters or stated the correct relationship, but not both. Okay, and then step 2, essentially correct if we include the following 3 components. Identify the correct test procedure by name or formula. I like the name, not the formula. The formal name for this test is a 2-sample z-test for the difference of 2 proportions. A 2-proportion z-test is equivalent. Note that the use of random assignment satisfies the randomness condition. So treatments were randomly assigned. You should not have said people were randomly selected for the study because they weren't. These were volunteers. So treatments were randomly assigned. I assume they were volunteers. Note the use of we checked that already. Check the approximate normality of the test statistic by citing all 4 counts are larger than some standard criterion such as 5 or 10. So you can use 5 here if you want, or 10. Doesn't matter, it's the same thing. So essentially correct if you have all three of those, partially if you have only 2 out of 3. For the randomness component, it is minimally acceptable to say random assignment check, but so minimally acceptable. Treatments where randomly assigned is better. But it is not acceptable to say random check or SRS check. The important concept here is that a random assignment and not random sampling that is required. If the response implies the study used a random sample, the randomness component is not satisfied, regardless of whether random assignment is correctly addressed. Okay, I don't think you did that other note. So I had all 3 of those, so I got an E. If you were missing one, you got a P. Step 3, essentially correct if you calculate both the test statistic and p-value consistent with the stated alternative hypothesis. Boom, boom. Partially correct if the response correctly calculates the test statistic but not the p-value, or if the response calculates the test statistic incorrectly but then calculates the correct p-value for the computed test statistic. It's pretty nice. Or if the response says a correct p-value but no test statistic is shown. So the p-value is considered correct based on the whatever hypothesis and z-score you have. So it needs to be consistent with those things. Step 4, okay, so I have 3 E's so far. Step 4, essentially correct if the response provides a correct conclusion in context. There's a lot of context in there. With justification based on linkage between the p-value and the given alpha. So alpha was given in this case. So I identified alpha here. You could have put 0.05 here. Actually, p-value less than A would have worked here with no mention of alpha because they defined it. But if they hadn't defined it, you would either have to define alpha here or you would have to put 0.05 here. Okay, that's essentially correct. Partially correct if the response provides a correct conclusion with linkage to the p-value but not in context, or a correct conclusion in context but without justification based on linkage to the p-value. So if you skipped the first sentence and you just said there is sufficient evidence, that would be partially correct. There is sufficient evidence, and then you finished out this whole sentence. If your p-value is incorrect in part 3, you can still get essentially correct in your conclusion. That's why if you can't figure out how to find a p-value, make one up. Every single time, make one up and write it down as if you calculated it, and then write your conclusion based on that. Because every time you'll still get essentially correct. Hopefully nobody is accepting the null hypothesis instead of failing to reject the null hypothesis. Okay, here we had 4 parts, so each E is worth 1 point. And you rate yourself holistically based on how you did overall to determine if you would round up or down. All right. Hopefully that was shorter.